Hello, everybody. Really great to have you here and great to be here. So, my name is Daniel, as you can see, um, and I'll be your ML, AI, and deep learning instructor or tutor, whichever one. If you have any issues, I'll be helping you through them, and I'll be showing you how to build very amazing AI use cases. So I would have to just give you very quick background of what AI is, what ML is, and then what DL is, right? So AI, I'm sure it's something everybody you must have heard about, and if you're here, you probably you want to know more about it, right? And then you want to use it, you want to do amazing stuff with it, right? So AI is basically artificial intelligence. It's in very simple terms how computers use their brains to behave like humans without being programmed. So that means they can learn like humans, they can do things like humans do, they can talk like we talk, they can understand language like we understand language, they can see like we see and understand what they're seeing. They can predict what's going to happen tomorrow to some extent, to a particular extent. So yeah, basically they're doing what humans can do, but they learn to do them themselves. That's what AI is, artificial intelligence. It's not human intelligence. It's a different kind of intelligence that can do what humans can do. Intelligent enough to do what humans can do. All right. So once we shift from AI, which is like a very large body, we're going to go to inside, and then we're going to talk about ML. So ML is machine learning. Machine learning is just an aspect of AI. It's not. Um, Sometimes some people say them interchangeably. They're not the same. They're not entirely the same. AI is a larger body. ML is a subset of AI. So ML means machine learning, basically how machines learn, but how they learn with data. So what that means is you give it a lot of data, it looks at that data, it learns that, oh, so from this data, this is what always comes out of the data, right? I'll explain what that means. And next time when you give it something similar, it will say, oh, I recognize this. I've seen this before. When I was being trained, I was given a lot of data, and this is what they told me that data was. So that means, and because this new thing you're giving to me now looks like that thing they gave to me then it has to be that thing, right? So let me make it more concrete. So if you have and you want to train an AI to recognize cats and dogs, something as simple as cats and dogs, you give it a lot of data, a lot of pictures about cats, or a lot of pictures that are called cats, and a lot of pictures of dogs, and then you tell it, oh, this is for cats and this is for dogs, and then it looks at the picture, it keeps looking at the picture a lot, it looks at a lot of them, maybe it could be 1,000, it could be 100, it could be 10,000, it could be 1 million, and then he looks at it over and over and over, and then in every image, he keeps seeing that the eyes usually is like this, the nose usually is like this, the mouth usually is like this, the hands are like this. So next time when you give it a new image it hasn't seen before, it'll check: does the eyes look like a dog's eyes? Does the eyes or like a cat's eyes? Does the eyes look like a cat's nose? Does it look, or does the nose look like a cat nose? Like a prediction and say, oh, this is a dog or this is a cat, right? It's as simple as that. So that's machine learning. Then deep learning is a different subset of machine learning. So again, we have a larger AI, then we have the ML, and then we have the deep learning inside it, right? Very is a subset. So deep learning basically means we're now using, for the classifications that I just spoke about, we're using neural networks. That's just it. Deep learning is basically neural networks. I'll explain what neural networks mean, because we're going to be focusing on deep learning. So neural networks are basically, um, they're like, let's just see them as the computer um, using, yeah. So the brain of the humans basically has small neurons that communicate with each other, right? So you could see neural networks as neurons that communicate with other neurons, and then make classification. It's as simple as that, right? So I wish I could draw here. I don't know. I wish I could draw. I wish I could draw. Okay, I can't draw. Um, from next class, I'll start drawing. So basically, you just have neurons. Think of neurons as a circle, a very small circle, and then there's another circle here. Okay, yes. This is okay. So yeah, you have two circles, right? This circle learns a particular thing, and then this circle tells this other circle that this one learns how to identify eyes, and this one learns maybe how to identify legs or whatever. So when you pass in the image, it basically says, "Oh, I see an eyes in this picture. Yeah, fantastic. I see eyes in this picture." And it will tell this one that, oh, that's the eyes, that's a cat eyes, right? And then so say, oh, that's a cat eyes. I also see cat ears. And then that information is passed to another neuron that now says, oh, you guys see eyes and ears, eyes and legs. I see ears too. And then this one takes all the information, eyes, legs, ears, and then sends it to another one. And then it keeps doing that until it gets to the last neuron and now tells you, oh, with all the information my previous neurons are giving to me, this is a cat. It's as simple as that, right? It's just that simple. Machine learning uses other techniques to do classifications, but deep learning uses neural networks to do classifications, right? That's just it, right? And so we're focusing on deep learning, right? So let me just quickly run through. I'm presuming that you've come from the Python class, so you should be familiar with Colab. But if you're not, I'll just quickly run through it again because I want this class to be as practical as possible. I want us to just jump into the code. So I'll just quickly share my screen. Okay, fantastic. Okay, so I'm sharing my screen. This was Python class. Oh, fantastic. Yeah, this was Python class. I'm just going to wipe that out. And this was how, when we're trying to create, this was what we did in Python class. Okay, so let's just call this Python first class so we can keep track. All right, and then we're just going to push this aside. Yeah, I'm going to push this aside. I'm not going to use this now, just in case you're just coming into this class. I'll just quickly show you again. All you have to do is just come here, type in Google Google Laboratory, and just click that. And then you'd see Google Colab here. You just click Google Colab, and voila, you're in Google Colab. And then it gives you this awesome set of tutorials. You could always come back to this as you go on in your deep learning course. So you just click File and then click New Book, and you're good to go. It creates a new notebook for you, but it doesn't give it a name. So it calls it Untitled. You have to give it a name. So you could call it Deep Learning, right? That's all. Deep learning, let's call it first class. And then it's saved. So how do I enlarge this? Let's see. How do I enlarge this? So I really don't know how to enlarge this. I think I'm just, okay, so if I do this, okay. So I'll just exit and continue, and then we'll figure that out as it goes. Okay, so deep learning, first class. So we've learned print statements in Python, and we're just going to come here because this is our guide. And so I'll explain some things that we're going to see on the Colab. so that you understand. Again, in coding, all you need to do is understand the intuition. You don't really need to have the syntax in your head, right? You could use the syntax, you could use your intuition to find the syntax. That's what Google is for. That's what Google is supposed to help you out with. Because if you have to keep all the syntax in your head, man, your head is going to just explode, right? Because there are a billion syntaxes to keep in your head. And then they're making more as time goes on, as the day goes by. All right. So these are the tools that you use to build a facial. Okay, so let me just explain this. So first of all, to build a facial recognition system, there are several things you need to keep in mind. So you cannot completely build a facial recognition system inside one Google Colab notebook. You need to depend on other people's code, right, to get access to certain things. For example, if you want to do number calculations, then you use in Python, then you use NumPy, right? So when you want to do number calculations in Python, you use NumPy, and then all you have to do to bring that into your own notebook is just type in import NumPy as MP. That's all. So with this, I'm going to have access to NumPy library. Libraries are a set of code that some other people have created to do specific things. And then for you, if you want to do those things in your own notebook, all you have to do is just type in import NumPy as MP. Sometimes you might not have them. If you are doing this locally on your system, you won't have them in your local system. So you might need to pip install NumPy, right? And then if you're doing on Colab, you would have to add this exclamation mark. You have to. If you don't add it, it's going to give you an error. So once you add that, and then click this to install NumPy. But in this case, we already have NumPy, so it's telling us requirement already satisfied. That's one of the beautiful things about Colab is that it gives you many libraries, many dependencies. You don't have to install them. They're already inside this Colab notebook. All you have to do is import them so you can use them. All right. So that. So for NumPy, this is for number calculations. We're going to have to use some other things like TensorFlow. So TensorFlow, there are basically two very common libraries that you can use for deep learning. The first one is TensorFlow. TensorFlow was created by Google for deep learning activity or deep learning tasks. Maybe to as you get to use it more, you understand what it's meant to do. But basically, for any deep learning task you want to do, you can use TensorFlow. The other one is PyTorch, but we're not going to be focusing on PyTorch in this course. We're going to be focusing on TensorFlow. We're going to be using TensorFlow to do some amazing stuff. So yeah, TensorFlow gives you many things to do. Deep learning tasks. Basically, just look at it that way. It's as simple as that. I will explain what all this mean. TensorFlow, keras, layers, dense, activation. I'll explain what all this means. But all you just need to know is that I'm pulling TensorFlow from Google Colab and I'm bringing it into my notebook so that I can use it inside my notebook, right? Then you can see here, now you see that this is different from TensorFlow import keras. Import TensorFlow as TF. There are two different commands. This first one means import TensorFlow as TF means instead of me having to write the whole TensorFlow to use TensorFlow, what I need to write is TF. So once I write TF, it will know that I'm talking about TensorFlow. So I don't have to write very long words. I just have to write import TensorFlow as TF and then just use TF in my coding. The same thing here to import matplotlib as .pyplot as PLT, and I just get access to pyplotlib. Pyplotlib is used for plotting, for doing your plotting. So if you want to see, maybe you want to plot the picture, you want your picture that you pass into Google Colab to show on Google Colab, you use pyplotlib. Or you want to do graphs, you use pyplotlib. You see how to use it as time goes on. Then NumPy, like I said, number calculations. There's pandas, there's shorttail, there are many of them, but let's just stick with this for now. So all you have to do is import NumPy, then import TensorFlow. This is going to be a lot for you to type, so STF is going to be a lot for you to type. So I'll just have to, so it doesn't take our time, I'll just have to copy it out and just paste it here. Okay, so the next thing we'd want to do is you want to mount your drive. So that means sometimes you might have your data in your drive. That's what your drive stores your data, right? So all you have to do is mount your data or mount your drive, which is what we're going to do right now. So I'm going to mount my drive. That means I'm going to give Colab access to my drive so that I can pull the pictures or the data from my drive, right? So connect to Google Drive, and it's mounting, it's connecting to my drive. Good. So in this case, you might not have access to what I have in my drive. What we can do is we can get a new data for you. I'm typing in any questions, so if there's any question, it should pop up here. Okay, so let's get back to the coding. So all you have to do is connect it to your drive and then connect it to the folder where you have your, connect it to the folder where you have your images. So somebody said, what is TensorFlow? Oh, so forgive me. I'm trying to put in wrapping a lot into a lot of definitions and some understanding into a very short time frame. So sorry, I skipped that. So TensorFlow basically means tensor flow. So what are tensors? The question should be, what are tensors? So tensors they are basically numbers. Tensors, they don't understand images like we do. They don't understand words like we do. What they understand are numbers, right? So what we have to do is we have to turn those images to numbers. We have to turn those words to numbers. So the numbers that we turn our words to or we turn our images to are called tensors, right? Now, like I said, when we're having Python class, computer takes in data, processes the data, and then gives out an output. Now, what that means is the computer takes in numbers. In the case of deep learning, processes the numbers, and then gives out an output of numbers. Then we would turn the numbers to something that a human being can understand. We'll turn it back to words, or we'll turn it back to images. So that flow of numbers, in this case, flow of tensors from input to processing to output is called TensorFlow. That's where the word TensorFlow is gotten from. So, but TensorFlow is just a library or it's just a set of codes, let's put it that way, a very long, large set of codes that helps you do many things with your tensors from the point of input to the point of output. That's just it. So your tensor is flowing from input to output. Tensor flow. I hope that makes sense. Tensor flow, right? It's as simple as that. Again, if you have images, you have words, you have to convert that into tensors, into numbers. So how to get the guide? Yeah, so that's TensorFlow. How to get the guide? The challenge now is I think we don't have access to the shared drive. If you had access to the shared drive, all I needed to do, or I need to do is, all you need to do basically is just click on the shared drive and you just have access to the code or the notebook, and I know you can now copy and paste. What other alternative do we have? What other alternative do we have? Okay, so I think I'll just need to do more explanations today, and then from next class, and then of course we'll find a way to send the notebook across to you, and then you could practice everything we've talked about. Right? I'll just need to do more explanations today, so you get a full grasp of what it's about, what deep learning is about. So again, so apologies for those of you that can't code. We're not actually doing coding today. We're not actually doing in-depth coding today, so it's fine. We're doing more explanations today. And then when you get the code, all you have to do is just run them to get hands-on learning about it. Okay, so yeah, we're going to import our dependencies. Our dependencies are libraries that other people, or codes that other people have compiled and kept somewhere. And then we can use them to do amazing stuff in our own notebook. One of those libraries is NumPy. NumPy helps us do number calculations. Then we have TensorFlow. TensorFlow is basically, it helps us handle tensors from input to output, right? TensorFlow is built on, again, it's numbers, right? So it's built on NumPy. Excuse me, it uses NumPy. It's just that simple, right? So one other thing that library will be using a lot of is scikit-learn. I'm not sure we're going to use scikit-learn in this collab. Yeah, we're not going to use scikit-learn, but scikit-learn is a very powerful tool for machine learning and for deep learning too. But for this use case, we're not using scikit-learn. Then we also have matplotlib. Matplotlib, we can use matplotlib to plot. That's why it's called matplotlib library, matplot library. So we're using it. We can use it to plot different shapes or different graphs to see how well our AI in quotes is performing, or sometimes to see the images that we pass into the computer. All right. So I don't know why I forgot to mention. So for deep learning class, we're basically going to focus on facial recognition. We're going to build a facial recognition program or facial recognition software. So what that means is you pass it images, you could pass it images of yourself, and then it will recognize that it is you. That's what we're going to do here for the rest of from now to the end of the class, or the end of the course in 6 weeks. You're going to be able to pass in data into your Colab or your program or your software, and then it will tell you that, oh, this is JJ, or this is Scott, or this is Daniel, or this is Barbara, or this is Sandra, whatever your name is. It will tell you that, oh, I know this person, I've seen this person before, this is Sandra, right? So that's what we're going to do, facial recognition. So yeah, we understand what dependencies are. Don't worry if anything I'm saying seems a little far-fetched. The more you use it and practice it, you would get used to it. You will just understand it, right? You understand by practicing. That's what learning is. You understand by practicing. You don't understand by you look at it and say, oh, I don't understand. No, give it time. implement it, code it, you understand it. All right. So after we've imported libraries that we're going to use, one other thing you need to do is you need to tell the computer where you kept your data. So where should I fetch my data from? So that's where you have your training data, training directory. A directory is a folder where you keep something, and validation directory. That means directories where you keep different kinds of images. Now you see that there's training directory here and there's validation directory. They are two different things, right? So remember when I said when you feed in the computer data, it learns. That process of learning is you're training the computer. Let me drop this here. It's supervised learning. You can read up on that. Supervised learning. So the idea of supervised learning is you give it a lot of data and then you tell it that all this data I'm giving to you is data or images of Sandra, or images of Juliet, or images of Precious, right? You would give it a label and say, this image, taking this image, but the name of this image is Sandra, Joseph, or whatever name you want to put it, you want to give to it. That process is called training. You're telling it, you are supervising the training, you're supervising its learning. So that's, you're training it. So when you see training directory here, we just mean where it should get the images that it will train with, right? It's as simple as that. Let me see if I can find that now that we've included our drive. So you understand what I'm saying. So we have recognition. You just go into recognition and you'd see train and validation. And if you click in, you would see Daniel, Jennifer, and Mary. Now, if you come in, you would see a lot of images of Daniel. If you check another one, you see a lot of images of Jennifer. So let me just show you an example of what Jennifer looks like. It's a large picture. So this is Jennifer's picture, right? Jennifer's facial image. Right, so we could have a lot. I think we have about let me see. Okay, we don't really have a lot here. We just have, say, around 20, but that's fine. We can train with 20 different images from different angles, right? I'll explain why you need to have different images as time goes on. So yeah, so that's basically it. And then you put all that into different directories. So every image inside this directory is an image of Jennifer. Every image inside this directory is an image of Daniel. Oh, I just moved that. Yeah, okay. So every image inside this is an image of Mary. And then, so why do we have training and validation? So training basically means after you've trained it, you have to test it to see how well it performs. After you've trained it, you need to test it. So you give it a lot of images, you give it names of those images, then you give it images of that it hasn't seen. So again, let me show you an example. So we trained it with this training directory. They were going to test with this directory. So again, let me use Jennifer. So you see, it's not a lot. It's just about 5. We had more training examples. Now we have about 5 validation examples. So let's see. Yeah. So after we've trained, or while we're training, the computer would check to see if it can recognize this. After it has seen a lot of Jennifer, then it will now check, okay, now that you're giving me this image, can I recognize who is this person? Okay, this is Jennifer, right? Now remember, you can put any image you want here. It could be the image of your family members. It could be the image. It could be your own image, basically, right? It could even be image of celebrities. For this course, we'll be using image of celebrities, right? But you could just take a lot of image of your mom, of your dad, of yourself, of your friend, and then just put it into the directory, put it into your collab, into your drive rather, and then put it into create a recognition folder, create inside the recognition folder, create a train, and then create a validation, right? And that's all you need basically. And then open your collab and you can access it. So if you watch, all you need to do to show it where is just click on these three dots here, go to that train directory, click on the three dots and say copy path. Path means pathway to where the folder is. And don't forget to keep it, everything, put it inside a quotation mark. So if I do this, you see automatically, let me just wipe this out, right? So this is where the training directory is. Then the validation directory, where it's going to get to test from. Again, the same process, just go down, click on validation. Okay, click on validation recognition and then go to validation directory and then click on the three dots. It takes you to copy path. You can always go over this video again to help and then just double click it, right? So this just shows you where validation path is. So when I'm looking for what to test with, that's the computer, it knows to test with the validation images. Okay, so after we've created our test and our validation, training and test directory, the next thing we need to do is we need to use data augmentation. What is data augmentation? Data augmentation basically means adding varieties to your data, right? So what that means is if when I'm taking an image, or I have an image, the image is just of me facing the camera. What about when I'm like this? That means again, is what you teach it knows. If you don't teach it to recognize people like this, if it sees a particular person like this, it will know that this is the same person, right? It doesn't function like we function. You have to show it different things and say this is what it is. That's why it's called. So we have to supervise it throughout, right? So that's what data augmentation basically does for us. It helps us give different varieties to our data. It augments our data, right? So for some of our data, if it will shift how the image is. So for some of them, if the image is like this, it'll skew it because sometimes the person could just be like this, right? A different posture. Or sometimes the person could be zoomed. Sometimes the person could be zoomed out in the image. Sometimes the person could be upside down in the image, right? But your data doesn't have you don't have those kind of pictures in your data. What do? You need data augmentation. This image generator API, it generates images for your data, from your data, that will change how your data looks. Some of your data looks, right? Change how some of your data looks. And then to add that to your data, and then it makes your data as rich as possible before you now pass it into your neural network that now does the recognition. Remember, those networks that recognizes the eye, recognizes the legs, recognizes the ears, and then it keeps passing on information to other neurons, until the last neuron now tells you, oh, this is a cat, right? I hope we're flowing. Again, I'm just doing an explanation. We'll do more coding from next week. You just need to have an intuition as to what's happening here. Don't worry about the code. It's simple, very simple actually. You just need to have an intuition as to what's happening here. Okay, so you could just read through. So image data generator, basically, that's this. It helps you generate other angles for your image, for your training image, flips your image, it zooms your image, it rotates your image, it revolves your image. Yeah, that's what's happening here. So let me run through it again. You import your dependencies, then you show it where to find your train and your test data or validation data. right? So once you're done with that, it goes into there, or you create your image data generator that helps to variate your data, give more variation to your data, right? So it helps to flip your data, rotate your data, um, um, zoom your data, skew your data. If it's standing straight, it will skew it, um, and many other things, right? So that's what's happening here. Don't worry when we start coding to make sense. And then once we have that, so this, after we've created it, it goes into your directory, your train directory here. Don't worry about every other thing, just focus on where my cursor is. It goes into your training directory that we defined here. We told it this is where this is our training path. So you now tell the image data generator now goes into our training path, which is here. And then it goes and does all those things I've mentioned: rotate, zoom, flip, skew to the data. All right. And then it automatically tells you how many classes or how many um, people or how many classifications are in that training directory. In this case, we have three. Don't worry about the four here. It was three before, and it was three because we have just Daniel, Jennifer, and Mary. Or it is three because we have just Daniel, Jennifer, and Mary. So if we rerun this, you would see that it would turn to three, right? So it will go into that image, that training directory. It will count how many images are there in total. It's going to Daniel, count how many images are in Daniel. It's going to Jennifer, it's count how many images are in Jennifer. It's going to Mary, to count how many images are in Mary. It will join everything and tell you, oh, I found so and so number of images in your training directory, and I found 4, 3, 2, 10 classes, depending on how many people you have there, right? It's just that simple. Then the next thing is, now that we have our data, we've variated our data, our data is now rich enough from different angles. The next thing to do is now to build our neural network. It's as simple as that. All we need to do is build our neural network. Now, this one is, I need you to pay very close attention to it. I'll touch it. I'm pretty sure you might not get that first, but when I'm coming back to it next time, it will be clearer. All right, don't worry, it will be clearer. Just try and hold on to what you can hold on to. When I'm repeating it again, it will be clearer. Okay, so there's something called transfer learning. The concept of transfer learning is, or what it means is, we built, or a very large company that has a lot of money has trained neural networks. Neurons are connected, and neural networks. So it has trained neural networks to understand or to see images and understand what images are. So that means if you pass an image into that neural network, it knows where the eyes is, where the nose is. It knows what a face looks like. It knows what a cat looks like. And then what you want to do is you want to tell it, oh, since you can recognize a face, now I want you to recognize a particular face. So I'm going to take the knowledge you have recognizing faces, and I'm going to tell you that when you now see a particular face, my mom's face, you will know that that is my mom's face, maybe Stella's face, or Barbara's face, or Jennifer's face, right? Because if you were to train create a model from scratch, it might not perform very well because it takes a lot of time to train neural networks that can perform very well, that can see people and know, that can recognize people easily. So you don't have to go through that long hassle. You probably don't have the compute. Compute means the computer that can calculate those numbers, like a lot of numbers, because you need like 1 million images. Where would you store 1 million images, right? How would you get the GPUs? GPUs are very extremely expensive to train, and you need a lot of them to train a lot of models to recognize images. So what do? Companies like Google, Tesla, Microsoft, and some other big companies, right? They already have trained models that can recognize certain things. So all you need to do is take that model and then apply that model to your own use case. That means streamline it and say, oh, I know you can recognize faces, but I want you to focus on only recognizing my mom, my mom, my dad, and my brothers, right? So that's what we're doing. We're going to take that very largely trained model. We're going to take its knowledge, transfer that knowledge into our own neural network, right? And then from our own, with that knowledge plus our neural network, make classifications. So that's why it's called transfer learning. You're transferring knowledge from a model that was trained, or neural networks that was trained on very large data sets for a very long time. Sometimes it takes months to train. Sometimes it takes years to train. Now that it has learned those things, and they're giving it to you for free, take that knowledge, add your own neural network to it. Your own neural network will just basically tell it, oh, this is my mom, my dad, and my uncle, or my friend. Add your own to it, and then from there you have a very powerful model that can do facial recognition classification. All right, so that's just the idea. You're transferring knowledge from a very well trained neural network into your own neural network. So that's what's happening here. Don't worry about all this. You would code it and then it will make sense. Now, let me explain what model.compile means. So after you've created the model, you've called it model, right? In AI, we call our AI neural networks model. You could put it that way. So after you've created it, a model for classification, a model is like, see it, I said we have different neural networks. We have one neural network, one neuron, another neuron, and that neuron, and that neuron. But you have to connect those neurons to each other so they can pass information to each other. That's the process of compiling, right? So you compile those neural networks, those neurons together, right? Um, And to compile it, you need three parameters. You need optimizers, you need loss functions, and you need metrics. I'll explain what that means. Just know that you need optimizers, loss functions, and metrics. You need to tell it optimizers, loss function, and metrics. So on that note, I would stop here because I think at this point it will get more complex if you don't. You need to digest this and understand this. I wish I could ask questions to see what you picked from it, but let me just quickly run through it again. So first things first, to build our facial recognition software, you need to import dependencies. You need to import dependencies like NumPy because we're doing number calculations, right? Again, I told you computer only understands numbers. It doesn't understand images or words like we do. It understands numbers. So we need to, first of all, we have to find a way to turn those words and images to numbers, and then we have to do calculations on those numbers, right? So we need NumPy for that. So we import NumPy. Google Colab gives us that ability to it has many of these libraries or dependencies. All we have to do is just import them into our own notebook, right? So you import NumPy, and then you import TensorFlow. TensorFlow is for tensors. Once you've converted your numbers to tensors, TensorFlow helps you handle those tensors from input to processing to output, right? That's what TensorFlow does. And built on NumPy. And then there are other things inside TensorFlow that we would use, but don't worry about that now. Then scikit-learn is a machine learning library tool that used to do machine learning, but it's not particularly for deep learning, it's for other machine learning. Then we have matplotlib.pyplot for plotting graphs. Then the next thing we need to do is we need to tell our computer or our program or our Colab where to find our images. Now, we need to have a training directory and a validation directory. Training for teaching the model what our face looks like. So that's where it's going to get images to train on, learn from, and then validation or testing is where it's going to um, test to see if it truly understands what you've been teaching it. It's going to use some other images to check. Oh, he said this is Jennifer. Let me guess. And then if it guesses correctly that this is Jennifer, it will use the validation images to guess. If it guesses, validation directory will send it one image. It will make a guess. Then it will check, am I correct? Was that really Jennifer? Right? So that's what the validation is for. It's to test the model to see how well it's performing. Then after that, you need to augment your data. You need to get, if you don't have a lot of data, sometimes you even have a lot of data, but you need to make your data as rich as possible. You want images to be from different angles so that your model can recognize people that are not particularly facing the screen. Maybe they are facing this way, or they are facing up, or they're facing down, whatever they're doing, or they're zoomed in. You need to teach your model to understand that, and to do that, you need an image data generator. So that means you don't need to go and snap the person bending, doing all those poses. All you need to do is get your image data generator, and then use that to just apply that to your image. It automatically happens. So what that does is it will go into your training directory, and then it would count how many images you have in your training directory. Say you have 10 folders, it will be 10 classes here, and then to count how many images you have in all the 10 folders, and then put them together and tell you, oh, I found this number of images in so and so number of classes or number of directories. Then after you've gotten your data ready, the next thing you need to do is to build your model. And I said you're going to use transfer learning here. Transfer learning is a model that has been, neural networks that have been trained on very large data with very large amounts of compute for a very long time. And then you take the knowledge they have, and then you add your own little neural network here. Don't worry, I'll be more explanatory next. It's more pictorial next week. You take your own neural network, and then you add that to the big large network that has been trained, and then it begins to recognize you in particular. It begins to recognize your mom in particular. It begins to recognize you, your friend in particular, right? So that's what this is for. And then, of course, after you've created the model, different neurons, you need to now compile them using optimizers, loss functions, and metrics. And so on that note, I'm going to stop there. And I'm going to ask if anybody has any questions. I think I still have about 5 minutes to spare. I'm sorry about the notebook not getting to you. We would have to sort that out before next class, and then you should be able to run all this and see what they look like. Yeah, and then at the end of the day, you're going to make classifications with you would get an image from the internet, or you get an image from your mom or yourself that the computer hasn't seen before, and if you pass into the neural network, it will tell you this image is an image of so and so person, right? So that's what we're going to do. And yeah, you could use this in your house. So you could build a camera that recognizes you in your house. So anytime you particularly come into the house, to say welcome Daniel, or hi Jennifer, or hi, wouldn't that be cool? That'd be amazing, right? Yeah, so that's it. So on that note, I am handing over to, do I have any questions? I'm handing over to Mr. Our moderator. All right.
Okay, hi Daniel.
Yeah.
Thank you. Very nice one, nice one. So
Thank you.
we have a lot of comments on the comment section, but what we decided to do is we are telling the learners that they have to go back to rewatch the video in order for them to understand what we have taught today, and
Okay.
we are going to give the learner who understands better or who can explain to us better what they understand,
Okay.
um, a prize or a gift.
Okay.
So
Okay.
that is,
That's good.
yeah, that is what we told them, because there are lots of comments on the comment section regarding that. So we are still going to send the link of we were going to send the link on the comment sections.
Yeah.
So
For the
yeah,
notebooks.
learners, if you can send me the link, I'm going to send it down to the comment sections. So learners, don't be worried. We're going to send the links to you so you can access um, all the files.
Yeah. Okay. So yeah,
So
I'll just send that as soon as possible so that we don't break the flow. Yeah.
no problem. So that is all for today.
Yeah.
Okay. So thank you everyone. It's such a great honor to have you here from one to this time. So thank you. See you guys next week. And don't forget, we're also going to send the link. We're going to send your link for the next classes for next Saturday. We're going to send it to your email addresses so that you'll be able to um, come on board next week. Please still remain the same time. The link is going the timetable is going to be sent to you before Wednesday, just like Mr. Femi rightly pointed out. So keep in touch with your emails and keep in touch with your tab. So thank you. See you all next week. Have a wonderful weekdays ahead. Bye. Oh, Jonathan, you have some questions? Hello, Jonathan. Okay, yeah, bye everyone. See you next week, Saturday. I hope you enjoy the classes for today.